Let's work on something now called change of base formula. This is if we don't have very nice numbers and they're asking us to evaluate a log, and we can't really, do this how we've done it before by saying what, or saying 2 to what power is 64, and it's something that's going to use a calculator. We're going to have to use decimals in this case. So let's see what we're talking about here. So let's say we had log base 6 23, and they told us to evaluate this. Now in the past what we did was set this equal to x and use down and diagonal to make this into exponential form. So 6 to the power of x equals 23. You'll notice here 6 to any power that we know, 6 to the 1, 6 to the 2, 6 to the 3, doesn't come out to 23. Because 6 to the power of 1 is 6, and 6 to the power of 2 is 36. And 23 is in between that, so it's going to be between 1 and 2. We can have an idea about it, but it's not really something we can figure out without a calculator. So let's apply stuff we've learned before also. So I have an x up here. I need to move it down so I can log both sides in order to move that exponent x. So I've got x times log 6 equals log 23. And remember, again, I can divide both sides by this log 6 to move it over. So I've got x equals. Now I'm going to write it out, log 23 over log 6. So we can put that in our calculator now, log 23 divided by log 6, x equals, and we said between 1 and 2, so 1.74, I think that rounds up, 500. So just like we predicted, somewhere between 1 and 2. Now remember, the reason I can do this on the calculator is because this is log base 10, and that's what calculators can handle. So what we're going to see is these same exact problems, but I want to find the pattern here. Let's see how I can jump maybe from this directly to this. You see those same numbers? Log 23 over log 6. So this number over this number. And let's just use that pattern now for the rest of our problems. Instead of writing all those steps in between, it's okay if we skip around a little bit. And actually, let me sum that up down here. So they're asking us log base 6, 23. Eventually, that came out to log 23 over log 6, now with base 10, that invisible 10. So that's how we're going to do it from now on. Just go from the original right to that, because there's nothing really to say. We can just skip steps. So log base 5 of 30. Now remember, I can write that directly to fraction form. It's log 30 over log 5. And now I'll just throw that on the calculator. Log 30 divided by log 5. So my answer for this, 2.1133. You can even put x right here. Makes you feel comfortable about solving. Okay, so this is a change of base formula. What that means is originally this one had a base of 5, and we're changing it now to the base of 10, the invisible 10 right there. We're changing the base. This is the formula that does it. We are skipping steps, but that is the theory behind it. So let's say we had log base 6, 216. That has a base of 6. We can change that to base 10 by writing it with log 216 on top, log 6 on bottom. So in the end, throwing that on the calculator, log 216 divided by log 6. Ooh, that came out nicely. That was a 3. So sometimes the numbers do work out. Sometimes it's not so big a deal. All right. So we can keep doing these. Sometimes they flip to decimals, but it's still not a big deal. Log base 3, 2.6. So keep the pattern. That bigger number goes on top. The base number goes on bottom on the calculator. It's easy to put log 2.6 in, divided by log 3. So my answer is 0.8697. Alright, so our first example up at the top showed us the theory behind it. We are using down and diagonal and we're solving for x. But in the future we can just go ahead and skip ahead to rewriting it in change of base directly. Remember, change of base means we're changing that bottom base into the 10 that we can now use on the calculator. Because base 5 and base 6 and base 3 we can't use on the calculator until we change it to a base 10.